Slightly different today with our data. Some of you will think good news because for probability you do not mean mean or median or mode or range. I didn't hear anybody cheer. Yay! But probability, we need to review a little bit from 6th grade and then add on a little bit of 7th grade stuff. So from 6th grade, I just heard Mr. Lefebvre teaching this yesterday. So I know it's in there somewhere, we just gotta find it. Probability of an event. First of all, you know they're talking about probability when they show you that capital P in front of the parentheses. And then whatever is in the parentheses is what they want us to find. So let's say I am trying to find the probability of getting heads on a quarter. So they would write it as probability heads. And then you think, what are the whole, or what are all of the options? What are all of the possibilities that I could get on my quarter? Heads or tails. 2 possibilities, 2, I never have the right word to say that bottom part. 2 possible outcomes. 2 things can happen. I am hoping for heads. And how many chances are there of getting heads? 1. The part I want is tossing a head, which is 1 choice. How many possibilities were there? 2. So I have half a chance or 50% chance of getting the head. What if I wanted tails? Same thing, which is why at the start of a lot of football games, they toss a coin to see who's going to kick off and receive, because it's an equal chance for both teams. Is that making sense so far? Are you finding it in your 6th grade math brain? Somewhere? You don't remember?
Kind of. That was way too long ago. Yeah. That was actually a year ago yesterday. Technically, if you.
Somewhere around there, yeah.
Well.
Also, all probabilities have to be between 0 and 1 somewhere. So if I wanted on my coin some other option between heads or tails, I would just write 0. On a quarter, there isn't another option. It would be impossible to get something other than heads or tails.
Yes side. That's happened before.
Is it really happening?
Yeah, I see it on that.
I feel like it was staged.
It could also like start spinning and then stop. That's happened too. So you got a 33.3% chance.
Okay, I guess there's a very like 0.0001 chance it could land on its side. Equally likely, that would be what we just talked about, right? Heads and tails, equally likely. And then a certain event. What if I didn't care if I got heads or tails? I just wanted something. How many choices could I have? 2 out of 2, which would simplify to 1. I have to get something. It's not just going to keep floating in the air. It's going to fall, and I have to get something. But good news, on Earth there is gravity. Good.
What if you're doing this at Mars or something?
No, I'm afraid of heights, so I'm not going to do it on Mars. Not going to happen. Okay, here's some other questions like that. It's right on your paper. Ooh, I'm out of order. There we go. Okay, so this one I'm switching to, the official math name is a number cube. We say dice. So here's my capital P for probability, and I would like a 3. So now I have to think, what were all of the, I think I have this. What were all of the choices? Look at that. What are all of my choices? 1 through 6. I have 6 choices. Can you picture Sorry? Where you have those little game pieces and you're trying to get them to home? I'm really hoping that I roll a 3. So what are my chances of rolling a 3?
Oh,
I got a 5. I really wanted a 3. There was 1 out of 6 chances of that happening. Or Trouble has a dice that you pop the bubble in the middle. This time, oh wait, how many possibilities are there? 6. Yes. This time I don't care if I get a 3 or a 4. 2 out of 6 chances. Ellie says, should we simplify that? Which would be 1 out of 3. This is just simple probability from 6th grade. The next time, ooh, how many choices are there? 6. I don't care if I get a 1, 2, or 3. 3, 6, or do you remember what we said about half? Equally likely to get it or not to get it. How many choices on here? I see a pattern. I do not want 2 or 3 or 6. Oh yeah, there's 3 other numbers that I would like. Or equally likely again. I do not want 1, 3, 4, or 5. 2 left that I want out of something less than 4. 1, Savannah? Close. Something less than 4. Addison? 1, 2, and 3, right? Oh, equally likely again. Questions, concerns, comments so far? That was just regular old probability. Ready for 7th grade? Yes, we are ready. 2 questions we need for 7th grade. The first one is, what if you're doing probability twice in the same problem? I can't think of a game like this, but it could happen. Where I would like to roll a 2, roll a 2, or toss my coin and get a heads at the same time. So what's my probability of rolling a 2? 1 out of 6. Plus, I would like to get heads. Any suggestions on what to do with that? You do times them. We just answered the question. What do we do if there's probability twice in the same problem? We multiply. Ooh, how do we multiply? Yes, Preston, thank you. Multiplying fractions is the easiest fractions. You just go straight across. So I have a 1 out of 12 chance of getting the 2 and the heads. seventh grade question. They're gonna mesh together in a minute. Do you know the difference between an independent and a dependent event? Bryn? She said by itself, which is good. Can you think of anything else? Alone? I was also thinking not related. This is kind of a silly example. Preston's mom does not really care about how Bryn is getting home from school. Obviously, we want Bryn to get home safely, but Preston's mom doesn't really care about it. Those are independent things. Whatever Preston does to get home is not related to whatever Bryn does to get home. Can you see what I mean by that?
Unless they're going home together.
Which was going to be my next part. Do you know who Preston's mom does care about getting home? Preston and Preston's siblings. Those would be dependent. I never know the right word for this. Affects or effects? Affects? Preston, are any of your siblings here with you? Just you at the mouse board?
I'm not sure.
Okay, let's fast forward to next year. And Preston and who will be here? Lincoln are both getting picked up. But only Preston shows up. And Preston's mom's gonna be like, where's Lincoln? So then she would be concerned. Those would be dependent. She's not gonna go home without Lincoln. I don't think. Maybe?
Depends on the mood. I guess.
Yeah, I guess. But if Bryn goes home, does Preston's mom care? They're independent of each other. They're not related to each other. I know those are silly examples, but can you see what I mean? Okay, so these things affect each other. Independent, yes, Bryn's gonna go home safely, unrelated to the way that Preston goes home safely. Okay? So those are our two seventh grade questions that are gonna make more sense here in a second. Okay, so the bottom questions are more seventh grade style. We have these cards with these letters on it. I'm trying to find the probability of getting 2 I's. Well, how many possibilities are there? 10. Why did we put 6 on the bottom of all those dice ones? There was 6 possibilities. Now there are 10 possibilities. But if okay, they're all turned over. And I'm randomly going to pick out an I. What were my chances of getting an I?
2 out of 10.
1, 2. Did you read this? It says, oh, you replace the card. So picking that first I has nothing to do, it's not related to whatever happens next. I put the I back, and now I would like to choose another I. Allison?
I have a question. Can you simplify this?
Sure. What are my chances of getting another I? Pete?
With the S or just?
I had an I in my hand. It was in my hand for a minute, and then I put it back. Oh, look at that. The same chance of getting an I again. Here's a 7th grade question. What do you do if you do probability twice in the same problem? Multiply. Multiplying fractions is the easiest one. 400ths. If I simplify that, 2/50ths, which I could simplify to 1/25.
Do we have to simplify?
It usually is, but honestly, this is one of those situations like slope. If I had 400ths and that's not a choice, try simplifying and see if that's a choice. It could go either way, to tell you the truth. Okay, fresh start. I would like to pick an S. What's the chances of picking an S?
3.
3 out of 10 cards. If this was about my dice again, I would put a 6 on the bottom. If it was about my quarter, I'd put a 2 on the bottom. I picked the S. It was in my hand for a little bit. I put it back. Independent. The S and the I are totally unrelated to each other. What are my chances of getting an I? 7th grade question. Probability twice in the same problem. Multiply. 6 out of 100. If that's not a choice, I could also try 3 out of 50. Savannah, what do you think about getting a C? One out of totally unrelated, Addison. I'm going to try and get a T. Multiply straight across, Godiva. Sophie, do you think I can simplify 3 out of 100? Drake, I would like to get a T.
3 out of 10.
Totally unrelated, Zach Hellstrom, I would like to get an S.
3 out of 10.
Multiply, Preston.
9 out of 100.
Simplify, Bryn. Are we getting the hang of the independent? Yes? So far, so good? Moving on to dependent. Here's how I know it's going to be dependent. The question looks the same except for this tiny part right here. So the chances of getting an I, 1 2/10, right? But when I grab the I don't replace it. Now that's going to affect my chances of my second I. There's 1 left out of 9 cards. Wow, you guys are good. There's 1 left out of 9 cards. I will still multiply. But one thing is affecting the other thing. I don't have 2 I's to choose from anymore because there's 1 in my hand. Pete, multiply.
3 out of 90, and then, or 3 90s, and then,
You accidentally added.
or, oh yeah, 2 90s.
You're all right. We threw them off. start a new problem, pretend like all the cards are back. So I'm back to my 10 cards. Isabel, I would like an S.
It would be out of 10.
But I keep an S. That's going to affect the next thing that happens. They are dependent. Ellie, I would now like an I after keeping my S. Whew, that was fast. Allison, if we multiply that,
69.
Zach Boyce, what do you think about simplifying 6/90?
You can.
Can you think of what they might have in common?
3 and 30.
Yes, 3 and, oh, we're so close.
15.
We're dividing by 2 to get 3.
They're, 45.
Yeah. Oh, Taylor. 3 and 45? Say 3, Taylor. 3 divided by 3 is 45. Ooh. We made a mess out of it. Oh, no, we could have divided by 3 right away. Did you get the same thing at the end? No problem. When you start a new problem, pretend all of your cards are back. Allie, what do you think the chances are of getting a C? 1 out of 10? Nice job. Savannah, back to you. But I'm keeping my C, Savannah. I would like a T. You're very close. I kept this one in my hand, so how many are left? Multiply, Addison.
Oh,
You're fine.
3 out of 9.
No problem. My brain gets stuck too sometimes. Godiva, can we simplify that? Nice job. Last one. Sophie, I would like a T. Drake, I kept my T but want an S. Zach Hellstrom, multiply. You're close. You added accidentally. 3 times 3.
Oh, 9.
That's all right.
I had 2 down, so I was.
You're fine. Preston, 9/90.
Simplified,
Mm-hmm.
divide by 3, get 3 after.
Bryn.
Oh. This is 5. This is 3.
Uh-huh.
Wait. 10.
Here's what happened in first hour when I gave them the worksheet. They were convinced that you had to have 10 on the bottom, but it was a question about dice. Okay, so the only reason we were using 10 every time is because we had 10 choices. But if we had a dice, there would be 6 choices, or a coin would be 2 choices. Allison.
I divided 9 over 90 by 9.
Just faster, right?
Yeah.
Me too, but that's okay that they did it that way.